It's dark, isn't it? Is that dark, or is that my imagination?
Your brightness probably.
Okay. The first problem is identify each of these as a strong acid or a weak base. Or weak acid, weak base, strong base. Okay. What defines something as a strong acid or a strong base? Is there a word that you could come up with? TJ?
I'll go say 2 letters.
Okay, 2 letters, okay. What are your 2 letters? pH. Yeah, you could measure, you could put something in solution and measure the pH, and that'll tell you whether or not it's a strong acid or a strong base. While we're there, let's teach this. You know what pH is? pH measures the relative amount of what? Of this? What do the brackets mean?
Concentration, molarity.
What kind of concentration?
Molarity.
Molarity. So the brackets mean molarity. So the molarity of the hydrogen ion concentration is the pH, correct? And actually what you would say is, you'd say the negative on your calculator, say negative log of pH. Okay? The negative, what's the log, essentially? What is it? It's the exponent, right? So in other words, if I said to you, 1 times 10 to the negative 2, what's the pH? You have a 1 there. So you guys are very young. You didn't do log tables when you were kids. Well, you're still kids, but when you started logs, you have calculators, so you didn't have to worry about this. But if you have 1, if it's 1 times 10 to something, it's easy, right? It's easy. We don't. So what is that easy, or what's the negative log of that?
2.
2, yeah. So in other words, it's the negative log. In other words, what this is, you could say it's not negative log, you say it's the additive inverse of whatever the log of that is. We know the log here is negative 2, correct? The log of this value is negative 2, yes? Yes? Okay. So what's the log of 1? What's the log of 1? What's the log of 1? Put in log and hit 1. 0, right? Correct? So this would be, if I took the log of this, it would be the log of 1. The rule is this. If I have A times B, right? A times B, and I take the log of that. I take the log of that. What's the rule? What does that break down to? The log of A plus the log of B. You see that? You get that? It's the log of A plus the log of B. Yes? So the log of 1 is 0. So that's 0, correct? And then the log of this is going to be what? Negative 2. Why is the log of 1 0? What does that mean? I'm kind of teaching a little algebra here. What does that mean? The log of 1 is 0. How is the log of 1 0?
Because that means it came to the power of 0 is 1.
Yeah, in other words, it looks like this. This is 1 to the 0, right? That's 1 times 10 to the 0, right? Isn't that what that is? Right? Times 10 to the negative 2. Isn't it?
Yeah.
Right? Yes? What's 1 times, what is 1? 1 is actually what? 1 is actually what? 10 to the 0. Couldn't I substitute in that? Yes? 1, if I was going to put 1 in scientific notation, it would be 1 equals 1 times 10 to the 0, correct? Because 10 to the 0 is 1. So I could simply replace 1 with 10 to the 0 if I want everything in base 10, couldn't I? Yes?
Yeah.
So this says, if I say the log of this expression, the log of this expression is the log of the first, 10 to the 0, okay? 10 to the 0 is 0. That's what they're saying. What's the exponent? What's the exponent? See that? The exponent is 0. So that drops out. Plus, not times, plus the log of 10 to the negative 2. 10 to the negative 2 is negative 2. Correct? But if I say, take the additive inverse of whatever I get, and I get negative 2, the additive inverse of negative 2 is 2. Correct? The additive inverse of negative 2 is negative 2. Negative times a negative is a positive, correct? You get it? Okay. That's the math. Did you know these rules for logs before? You did. You've had that in algebra? Okay. So we're going to be using a lot of this. We're going to be using a lot of this log business. So let's go back to pH. pH is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that all on the screen? Right? It can also be anything in between, correct? This is acid. What's 7? Neutral. How do you spell neutral? How do you spell neutral? How do you spell neutral? Look it up.
N-E-W-T-R.
And what? N-E-W?
Yes.
N-E-W. Look up on your phones if you have to. Look up the word neutral. We're going to be using a lot. It's one of the most misspelled words in chemistry. N-E-U, right? That's a U, not an A. N-E-U-T-R-A-L. N-E-U-T-R-A-L. I sometimes put an A in there and then I say, well, no, that's not right. I got to change that. So then I change it to a U and it looks like that. Okay. So neutral. Okay. Okay. Yeah. So like, yeah, exactly. This is H2O, right? This is neutral. And I always want to put an A there, but I don't. I had to spell it. It's just a persistent typo. It just doesn't go away. And this is basic. Correct? 14? Yes? For instance, is that on there?
Yes.
It's on there just. Okay, this is basic, like sodium hydroxide. This is HCl. What's your stomach? What's in your stomach? What's one of the main ingredients in your stomach? Water, good. I like that. Good. Excellent. And what's dissolved in the water? What are the two things? And what's digested in the stomach? Is food digested in the stomach? Something more specific than just food? Is bread digested in the stomach?
Yes.
It is? Okay. Well, yeah, I guess it can still be digested in the stomach. But does the stomach produce chemicals for the digestion of bread?
Yes.
Okay. No, that's not true. Starches are digested in what two areas? The mouth and the first 20 centimeters of the small intestines, called the duodenum. And what's digested in the stomach? What's ever left? Well, I mean, starches, carbohydrates are digested in the mouth, and it continues in the stomach, and then continues in the small intestines, I guess. But what is produced in the stomach that digests what? Fiber is digested in the stomach. No, not fiber. Thank God this is not biology class. Okay? I'm not really annoyed. Okay. What's digested in the stomach? Anybody? And some of you want to take AP, IB biology and not IB chemistry. Excuse me? No.
Proteins.
Protein.
Yes, I got it. We said protein.
Okay, I didn't. Fatima's getting very aggressive. I mean, you know what I mean? She's really like jumping out of her chair. If you could see her, she like is angry. Can you calm her down, please? She looks like she's ready to. Do I have to call security? Okay. So, yes, protein. I'm sorry, I didn't hear it. So, protein. So, what digests the protein in the stomach? This is not a tangent. Well, I guess it is a tangent, but it's a educational, well-meaning one that has everything to do with what we're talking about. There's an enzyme. There's an enzyme. What enzyme? Pepsin. Well, you got to speak up, okay? Isn't it horrible having a deaf teacher? Okay. Oh yeah, like you would learn so much better if I could hear you. Yes, absolutely, Abdullah. You're absolutely right. Okay. I now have gotten to the crux of the matter. Okay, right. Okay, now. So what that's the enzyme. What catalyzes that enzyme? What catalyzes it? In other words, if you don't have it with it, it won't digest it. Yeah. The acid. Okay, the H plus. Okay, the H plus catalyzes the reaction. Well, hydronium, I understand it. We're going to talk about hydronium in a minute. We're going to talk about hydronium. But, so where does it get its acid? Where does it get it? Where does it get it? Where does it get it? What's the form? What's the acid? It's produced in the stomach. It's produced. What kind of acid is produced in the stomach? Stomach acid. Right. Excellent. I like that. It's HCl. Now look up pH of the stomach. pH of the stomach. Look it up on your smartphones, and then we'll get back to that, okay? Yes? That's important. So HCl is very important. pH is very important. Molar concentrations are going to be very important. Okay, we're going to always we always work with molarity now. Okay, we're saying goodbye to molality. 1.5. What is it?
2, 3.5.
I can't hear a word you're saying.
1.5 to 3.5.
1.5 to 3.5 in terms of the pH. I always heard it was like 1. What's the concentration?
5.0 and 6.0.
Gastric acid.
Can you look it up?
5.0.
Is it in molarity? Is the concentration given in molarity? Haley, you want to help us out here?
Me?
Anna, you want to help? Anybody?
160.
Okay, we'll get back to that. Okay, so what is one of the main points? Okay, so TJ said pH. Yeah, you can measure the pH, but what is one of the main points that you know whether or not a acid is going to be strong or not? Anybody? It completely what?
Acid dissociation constant.
No, you can look at the acid dissociation constant, the Ka. You could, absolutely. But if you just look at the formula and look at solubility rules, what can you draw? What conclusions can you draw? Yes?
Whether it will dissociate completely in water or not.
Yeah, whether, exactly. Hey, are you okay today? Okay. She was, even when she looks cranky, she's extremely articulate. Yes, say that again. That was really well said. That's better than I could do.
Whether
She
the
forgot what she
acid or
said.
base would dissociate completely in water or not.
whether or not the acid or base would completely dissociate in water. So when it completely dissolves. What's another word for dissolves? That's a little bit better because sugar dissolves. What's the word? How do you spell it?
This,
OLVE.
dissolve.
No, I know how to spell dissolves. Thank you. It's on the board. But that's okay, Andrew.
Okay.
D-I-A.
Dissociation.
Dissociation.
Oh.
D-I-A.
T-I-O-N.
T-I-O-N? Dissociation. Okay, dissociation. Good. Okay, dissociates. Whether or not it dissociates. Which, does that completely dissociate HCl? Absolutely, positively, 100%, completely will dissociate. So that will dissociate. So is that a strong or a weak acid or base? What's the acid? An acid gives off what? Hydrogen. Is that going to give off hydrogen or hydroxide? Hydrogen. I just gave it away. What defines a base? Gives away hydroxide, usually. Gives away a hydrogen, usually. Hydrogen ion donors, hydrogen ion acceptors. Yes, but that's not altogether true. And we're going to look at the different theories on acids or bases. So, is that a strong or a weak acid?
Strong.
That's a strong acid. Strong acid. We'll say SA. Okay? What about this? What about sodium hydroxide? Think of your solubility rules. Is sodium hydroxide going to completely dissociate?
Yeah.
All the sodium. It's a sodium salt, guys. Come on, get with it. It's a sodium salt.
Yeah, well.
Okay? It's a sodium salt. And that's going to be a strong base. It dissociates completely. What about H2SO4? H2SO4. Sulfates. What do sulfates do? Look up. This is a tough audience this morning. Look up solubility of sulfate salts. Just look up sulfate salts. Never mind sulfate acid. Solubility of sulfate salts. Look it up. Look up the solubility of the sulfate ion. Solubility of the sulfate ion. Look that up. What do you got? I don't see everybody looking this up. This is rather curious. Hassan, are you
Yes.
on PlayStation or are you... Okay, I just thought I'd be honest. And you keeping an eye on him, correct? Excellent. And is monitoring his internet usage. Did anybody try to get on the internet before school today? Did anybody at home?
Like on our computers or just in general?
At home, in general.
Yeah.
And could you? I couldn't get on, and I called Edis a lot, and they said that internet was down all through the country. It sounded like kind of a lie. Doesn't it sound like we don't really feel like dealing with you, so we'll just say that the entire country is not having internet? Rashi, will you do something about that, please? Thank you. So what do we got, guys? What do we got? What was the question? Sulfate ions? No? Can you get back to me on that? Okay. So this is very, very soluble. Matter of fact, if someone says to you, would you like to have a glass of sulfuric acid? You know what you say to them?
No.
No, thank you. Okay? It's the one acid in chemistry lab, one of the common acids. There are a lot of acids that are dangerous, but one of the common acids that are always around that I simply want to avoid. And I see no reason for it to be in a high school. I'm saying it here first. I know people think that I'm crazy, but God, sulfuric acid. The only problem, people say, well, use diluted solutions of sulfuric acid. Yeah, but you have to make that from the big mama, the big bottle mama, the 17 molar bottle of sulfuric acid concentrate. I suppose you could buy the diluted solutions, but it just gives me the creeps, man. I've seen too many people ruin clothing and get burned and terrible. What about ammonia? Is that an acid or a base? It has hydrogen, so is it going to give up? What's it going to do?
Weak base.
It's a base. Why is it a base, Haley?
Because it will accept a hydrogen ion.
It'll accept a hydrogen ion. Okay, so we know why those are strong bases. Those are strong bases, etc. Now, ammonia is one of the most soluble gases that's out there. It's a very, very soluble gas. So it dissolves. At a strong base or a strong acid. Well, when something that has hydrogen available as an ion, like hydrochloric acid or sulfuric acid, and they dissociate. Remember I put the word over here, dissociate? In other words, it forms ions. So you have H2SO4 goes to H plus SO4. Is this balanced? Is that balanced? Is it balanced? What do you need to put in there? A 2 here, correct? Yes, you get that? You got to put a 2 there. Yes? Okay. So if I dissolve, if I dissociate 1 mole, as is written here, 1 mole of sulfuric acid, how many moles of acid ion will I get? 2 moles. You see that?
Yeah.
You see that? That's an important concept. So this is dissociated. Yes, do you see that? Now, what's happening in the water? Well, what's happening in the water is this. You get the sulfuric acid and you're adding it to water, correct? Well, what's happening is the water looks like this. Looks like that, correct? What happens is you get this. What kind of bond is that? Yes, but it's bringing, in other words, it's just this, correct? Going to there. What kind of bond is that? Look this up right now. You guys are not very good this morning at looking things up. These are important things. Has anybody got the solubility of the sulfate ion? Anybody have information on that? Should we go back to that? Okay. All right, look up this. What is the name of the bond between 2 atoms where both electrons come from one of the atoms? Covalent? No. Something else. I need an adjective. What kind of covalent bond is it? No, if they're 2 different, he said polar. Well, if they're 2 different atoms, they'd be polar. Okay, so yeah, those are polar because, I mean, these are polar too because they're 2 different atoms.
Dative covalent?
What is it?
Dative covalent.
I can't hear you.
Dative covalent.
Covalent?
Dative.
What'd you say? Coordinate covalent? Look up coordinate covalent bond. You're guessing. I don't like the guess.
That is.
All right, read it. Read the definition there, Andrew.
A covalent bond is formed by 2 atoms. Okay, hold on. It's loading. Low.
See? You see what guessing does? You're not really sure. You want to get back to me on that? This is really important. This is on your test. Special announcement. This is on your test. What is it, Andrew?
A coordinate bond, also called a dative covalent bond.
What kind of bond is it?
Coordinate.
Coordinate bond. Okay.
Is a covalent bond in which electrons come from the same atom.
Where electrons come from the same atom. So the oxygen is supplying the bond, oxygen is supplying the electrons, which are forming the bond. You see that? You see that? So there's where my two hydrogens are going. They're forming this. They're forming that. You see that? They're forming that. And I'm going to have two of them. Plus my sulfate. You see that? You see that? But what we say is we don't really worry about the water. We don't really worry about the water. More on that later. But we can get rid of the water. Okay? We can get rid of it because there's still some water over here, but there's so this is called the hydronium ion. Hydronium ion. And the hydronium ion, so when you see this, that's just a shorthand way of writing this. That's just a shorthand way of writing that. Okay, so when I write this, I really mean the hydronium ion. Is that okay? Are you okay with that? You sure? Okay, so what happens is this. That's the formation of acids, okay? You get that formation of the hydronium ion, correct? Well, let's look at this. Let's look at this. What happens is in water, I'm going to have okay, water's going to come in here and a hydrogen is going to go there. A hydrogen is going to be hooked onto that. Clear? And you're going to form NH4 ion, the ammonium ion, and what's left over? If I take a hydrogen off the HOH, what's left over? If I take a hydrogen off HOH, what's left over? Because remember, it's leaving the electrons behind. See? This is, what kind of bond is that? It's a coordinate bond. Right? So it's leaving. So this is going to be what? This HOH is going to be the hydroxide.
So it's going to be a base.
That's right. So ammonia is a base. Ammonia is a base because it accepts that proton. It's a proton acceptor. You see that? It's a proton acceptor. Just like hydroxide. You see this? That hydroxide is a base. It accepts a proton. See that? So this is a proton acceptor. A proton donor is an acid. A proton acceptor is a what? Is a base. Look up Brownsted-Lowry acid-base theory. Brownsted-Lowry acid-base theory. All right, we'll talk about Brownsted-Lowry and Arrhenius theories after our commercial break. Excuse me?
How do you spell shred? Shred?
What did I say?
Brownstead.
Brownsted.
Stead.
Yeah, B-R-O-W, shmishma. Okay, so that's the end of That's the end of, now, oh, let's not end right here. So, do you think that ammonia is going to be a strong acid or a strong acid, strong base, weak acid, weak base? So what do you think ammonia will be? First of all, we know that it's a base or an acid.
Base.
It's a base. Do you think it'll be a strong base?
Yeah.
No, it's a weak base. This doesn't happen that much. I mean, it happens, and it will be a base. And it doesn't take a tremendous amount to be a strong, weak base, so to speak. But it is basic. Ammonia is basic. It is basic. It can be a strong, weak base. That's my terminology. It can be nasty. It can make ammonia so it's really nasty. Okay? So it's a weak base. So you have those strong. So sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. And sulfuric acid is a strong acid. And ammonia is a weak base. Did we look up the solubility of the sulfate ion yet? Google that right now, and we'll give you 15 more seconds. Solubility of the sulfate ion. Put it in. What do you got? Solubility of the sulfate ion. All right, you want me to tell you what it is? If you have like a light metal, like magnesium sulfate, sodium sulfate, those are very soluble. The sulfate ion is pretty soluble, especially when that light metal is really, really light. Because hydrogen is actually acting like a metal or a non-metal. What is hydrogen acting like, a metal or a non-metal? I'm not asking you what you think it is. Obviously, you know, it has no characteristics of a metal if you're used to handling gold or silver or iron. But what's one of the characteristics of a metal? Does it give up or accept electrons? Gives up electrons, becomes positively charged. Left side of the periodic table, right side of the periodic, yeah, okay. So when the sulfate ion is attached to a light metal, it's very soluble, sulfate. Well, if you look up all your sulfates, it's like a solubility rule. Yeah. It would be very, very advantageous. Very advantageous. And maybe the next video we'll look at them. But looking at and maybe memorizing, it's a very short list, your solubility rules. Okay? Yes, especially with acids and bases. Yes, good. All right.